this example, you're having to sketch regions corresponding to each of the following. Now these are more complicated, complex number graphs that you're going to be looking at. So look at the first one. I'm going to do this first one using the geometric type method, but you can use the algebraic method if you want to, and check out the textbook for that. The algebraic method is the one where you make the substitution z equals x plus iy, and then you work through that way. But I'm just going to do this geometrically. So what I mean by that is, I recognise that I've got here the modulus signs. Remember that the modulus signs mean a distance from a point, and normally that point is the origin. So the distance from a point is, and in this case it's this value here, 3, in all directions. And that corresponds to a circle. The only shape that has the same distance from a central point is a circle, because the radius is that distance. So it's a circle with the radius equal to 3. Now what we have to do is think about where the central point is. And you can see here, I'm going to rewrite this now. I'm just going to expand this bracket out. So we have z minus 2 plus I. Mod of all of that is less than or equal to 3. And what I can see there is I've got a translation, and this will correspond to the center of my circle. The translation, remember this is the real part, so this will be left or right, so it's actually plus 2 that way, 2, the opposite sign. And here, because this is a plus I, we must be translating down 1. So it's going to be a circle with a radius of 3 and a center at 2, negative 1. That tells us what our graph will actually look like. So we know all the information that we need now to graph. The other thing to look at, actually, that is important is that we have a less than or equal to sign. Okay, what that means is that we're going to shade the region that's inside, because a less than means inside, and because we have an equal sign, we're going to use a solid line for our outside of the circle because of the equals. Okay, so if we just had a less than sign, that would mean we're interested in all the points that are less than 3. That's not including those points that are a distance of exactly 3 on the edge of the circle. So if we had a less than, we'd be using a dotted line. So that's what we need to know to sketch. So let's sketch it. Get ourselves some axes and just put some tick lines on there. And you'd be measuring these so that they're nice and equal. These are not as equal as they could be. Okay, so we're going to translate across 2 and down 1. That's our center of our circle. And the outside edges are going out to 3. So we'll just go 3 in each direction. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. In that direction. Okay, and just graph it in light blue. Now with this, it's just enough to put the center of your circle, which is 2, negative 1. You might like to put the edges here too, so this would be 5, negative 1, and maybe another one of those points, maybe this one up here, so adding 3, so this would be 2, 2. Okay, so showing those various parts. So that's the graph for that function. Now looking back, always look back at the question when you think you're done. That's my advice for everything you do in Spesh. Look back at the question, because I look back now and I see, oh, it was a less than or equal to question. So I need to make sure that I'm showing the less than or equal to. And it's great if you actually put the equation for the line or graph on your graph as well. It's a less than or equal to, solid line for the equal to, and then because it's a less than, we shade that circle in. Okay, so that's for that first graph. Let's look at the second graph now for B. We've actually got here 2 graphs. We've got Z such that 2 is less than the modulus of Z, which is less than or equal to 4. Intersection, so that's the crossover, where the 2 graphs cross over each other, with Z such that pi on 6 is less than arg of Z, which is less than or equal to pi on 3. Okay, we've really got a few things going on here. So let's break it down and look at just the first thing. So looking at just this part first. Oops. So we've got z, and I'll actually just write down this part. 2 is less than mod z less than or equal to 4. The fact you've got modulus signs here tells me that we're looking at a circle. And the fact we have two sides here actually means we're looking at two circles. And I'll show you why that is. Let's look at this first half here. We've got 2 is less than mod z. And if I just rewrite that, we've got mod z is greater than 2. Okay. I've also got another one here, which is mod z is less than or equal to 4. Okay, so we've actually got two circles there, and if I highlight them, I'll write around them in red. It's these two here. So both of these are saying that we're at the origin. There's no translation here. So the centres are at the origin. And you can see you've got different distances from the origin here too. Now I'm going to actually start sketching this. I haven't even done this bit yet, just because I know I'll have to put this in anyway. So let's do this part first. So I'm going to sketch, and we won't actually need that much room. And I'll use these circles. So the first circle, actually I won't do that because we'll need some dotted lines. So we're going to put in just my tick marks, 1, 2, 3, 4, 1, 2, 3, 4. Really need to go up to 4. So the first circle, we have mod z, the distance from the origin is greater than 2. Okay, but it isn't an equals sign, so that means that this has to be a dotted line. Okay, this one's an equals to, solid line. So let's do this one first. Mod z is greater than 2. We know that that's a circle with radius 2. So let's put that in. It's a circle with radius 2. So that's this one. The next one is a circle. We've got an equal sign, so it's a solid line, and this circle has a radius of 4. So we're going to go around to 4. Oops, do that again. Yours will look better than that. Okay, now let's put in the shaded region for just this part here. We've got mod z is greater than 2, but it's less than or equal to 4. So that actually means that because this tells us we have to shade on the outside of the circle, this tells us to shade on the inside of the circle, the less than, the area that we'd actually be shading is this region here. So for these two parts of the graph, that's what we'd be shading. That's what we have so far. Okay, let's look at the remaining part of this question. I'm just going to get rid of this section here. So we have here, for the second part, we've got pi on 6 is less than arg of z, which is less than or equal to pi on 3. And again, you can think of this as two rays. So think of it as arg z is less than or equal to pi on 3. Okay, and then also this one here is arg z is greater than, because the greater than is pointing to arg z, pi on 6. Now I'm going to sketch that as well. I'm going to just sketch this. Now you could do all of these on the same axes. I'm just doing it to sort of show you all the steps here. Okay, so again with green, this is going to be a solid line because it's an equals. We've got pi on 3. Pi on 3 is sort of there-ish, about there. And the other one we've got is a dotted line, pi on 6, and that's going to be dotted because it's a less than, and pi on 6 is sort of there, somewhere there. Okay, now let's look at what we're asked to shade in. Arg of z has to be bigger than pi on 6, so that would be on that side, but it has to be less than or equal to pi on 3. So that means we'd be shading this region here. That would be the region we'd shade for these two rays. So we've got two circle regions that came from here, from this graph here. And we've got two rays that came from this graph here. So whenever you have an inequality where you've got two less than or equal to signs, one on each side, you're going to really effectively have two graphs. Now the last part of this is putting these graphs all together. So let's check it out. We've got, what we have to do is take these two graphs, so our first graph, and we have to find the intersection of those graphs. And what that means is find the area where the shaded regions overlap. So overlapping regions. That's the way to think about it. So if we do this as our final graph now, and again you could do all of these on the same axes, you don't have to be doing them in pieces like I have. I'm just going to sketch these now, so I'll do these in our first graph. We had our circle at radius 2, our big circle at radius 4. That's better. And we had our two rays. One was a solid ray at pi on 3, and one was a dotted ray at pi on 6. Now let's look at combining the two. Going to just label my axes as well. Where are the shaded regions overlapping? Well, you can imagine if you put this graph on top of this graph, you'd have your line and your dotted line, and your region that's shaded would be all of this region. The only region that corresponds is that shaded region there. So when we shade this now, what we can do is just shade this region. We wanted the region that's inside, inside those two circles, and we also wanted the region that's sandwiched in between those two rays. So I'm just going to put a box here that says region required as well. So we've shown that off. Okay. Now this particular shape here, the rays, is something you'll see a lot of. This one here is actually called a torus, or if you want to, it's also called a donut. That's the kind of just slang notation you can call that. So when you have two circles like that, one inside the other, and you're shading that region around, it's a torus or a donut. So this shape is effectively made up of a torus, and then only shading one little region of that, which corresponds to the ray. So there's quite a lot going on in here. This is one of the more difficult complex number graphing questions that you get, and you really have to think about it in pieces. If it makes it easier for you, graph the two pieces separately, first of all, then to see where the overlap is, and graph your final.